Every app on your phone is a prisoner, isolated in its own sandbox. So how does it ever talk to the rest of the system? The answer is Binder, and it's the central nervous system of Android. Have you ever had a corrupted checkout and wondered what Git is actually doing under the hood? Forget files and folders for a moment. Think of Git as a giant cryptographic database where every piece of your project is an object with a unique hash ID. When you change a single line of code in a massive Java file, what do you think Git actually saves? It doesn't save a diff. It creates a brand new blob object, which you see highlighted here, containing the entire content of your modified file and gives it a new unique hash. So Git has your file content as a blob, but how does it remember that blob is supposed to be named activity manager service.java? That's the job of a tree object highlighted on screen. A tree is like a directory listing. It contains pointers to blobs for files and pointers to other tree objects for subdirectories. What really is a commit, besides just a save point? A commit object is the glue. As the highlighted text explains, it points to a single top-level tree object representing your project state. It also stores the author, the message, and critically, the hash of the parent commit, creating that historical chain you see with git log. How does Google say this exact state of the code is Android 14 QPR2 across 800 plus repositories? They use tags. A tag is just a human-readable label, like a sticky note, that points to a specific commit hash. The Android 14.0.0_R12 tag you see highlighted is a permanent marker, a promise that this commit is the official source for that release. You don't have to take my word for it. You can actually look inside these Git objects yourself. The command highlighted here, git cat file -p head, is your window into the Git database. It asks Git to print the contents of the commit object you're currently on, revealing the tree it points to, its parent, and the author. Why is it that after a fresh repo sync, Git status screams about a detached head? Most people trip over this. It's because repo sync checks out a specific commit hash for consistency, not a branch. As you see highlighted, head is pointing directly to a commit, not a branch tip, which is why it's called detached, and this is absolutely by design.
So, you're in a detached head and need to start coding. Your first instinct, git branch, is wrong. Here's what actually happens under the hood. You must use repo start. This command, which you can see highlighted, not only creates a git branch but also tells the repo tool to track it, a critical linkage you'll need later for uploading. Have you ever looked at the AOSP git history and noticed it's a perfectly straight line? That's not an accident. As the highlighted text says, AOSP enforces a linear history by forbidding merge commits. This is achieved with two key workflows, rebase for keeping your work up to date and cherry pick for backporting fixes. You've been working for a week and 50 new commits have landed on the main branch. How do you integrate them cleanly? You rebase. Instead of merging, git rebase, as described here, lifts your commits off, updates your base to the latest upstream version, and then replays your work on top, making it look like you started fresh today. A critical security fix lands in Android 14, but millions of devices on Android 12 also need it. You can't merge all of Android 14. Instead, you git cherry pick. This command lets you pluck a single commit from one branch and apply just that specific change onto another, which is essential for the backporting workflow you see highlighted here.
So your feature is finally done. How do you get it into AOSP? The one command you don't run is git push. As this text explains, nothing gets pushed directly. Instead, AOSP uses a code review system called Gerrit as a gatekeeper. You upload your changes to Gerrit, where they must be approved by other engineers before they can land. So, how do you actually get your local branch up to the Gerrit server for everyone to see? It's a single command highlighted here, repo upload dot. The dot tells it to upload changes from the current repository. This command packages your commits, creates a new change on the server, and gives you a URL to track the review process. A reviewer left feedback. Your instinct is to add a new commit, But that's wrong. The trick that took me 3 years to learn is that Gerrit wants you to update the existing commit. As you see here, you git commit -- amend, then repo upload again. A hidden change ID in the message links it to the same review, creating a new patch set instead of a new change.
Enjoyed the video? Hit like and subscribe for your regular dose of AOSP customization. Thanks for watching. See you in the next one.